Number 8, find the integral of 0 to 3 of dx over 1 minus x quantity squared is what? I notice on this one that x cannot be 1, and 1 is in the middle, so we are going to have to do a little bit of work. This is an improper integral, so we're going to have to actually split this into two problems. We're going to find the limit as I'm going to use a w. W approaches 1 coming in from the left of 0 to w of dx over 1 minus x squared, and then I'm going to have to add it to the limit as w approaches 1 from the right, and we'll be going from w to 3 of dx over 1 minus x squared. Oops, x squared. All right, so we'll add those two integrals together. So I'm just going to deal with the first one first. First thing that I'm going to do is do a u substitution. So I'm going to let u equal 1 minus x, which means du would be negative 1 dx. So I'm missing a negative on the inside and the outside. So I'm going to have negative the integral of du over u squared. And if I rewrite that, that would be negative the integral of u to the negative 2 du. And if I take the integral of that, the integral of u to the negative 2 would be u to the negative 1 times negative 1. So those are going to cancel out, so I'm just left with 1 over u. So this will be 1 over 1 minus x. Okay, now I get to evaluate it at 0 and w. So if I plug in w, I'm going to get 1 over 1 minus w. And if I plug in 0, I'll just get 1. And remember, we're finding the limit of this as w approaches 1 from the left. All right, and if I'm doing this, I know a 1 over, if we try to plug in 1, we're just not going to get an answer. So that doesn't help me out at all because I end up getting 1 over 0, which is undefined. That doesn't mean we can't do it. We just need to approach it a different way. So I know the picture of 1 over x, if you recall, looks like this. So I can tell it's something like that, but we're used to having the x be first. So if I have 1 over 1 minus w, I'm going to multiply the top and the bottom by negative 1. So I'm going to get negative 1 over w minus 1. And what that does to this graph right here is move it 1 to the right. So my asymptote is going to be at 1 instead. And since it's negative, it flips the quadrants that my graph is in. So this is what the graph of 1 over 1 minus w looks like. And we would like to approach 1 from the left. So I'm approaching 1 from the left. I'm headed up towards infinity. So this limit is actually going to equal infinity minus 1 or infinity. And since I got a limit of infinity here, I can really stop. It's not going to matter what I do in this next part because I already got that this is going to diverge. So this is going to be choice E. Right, number 9. Which of the following series converge to 2? All right, so we've got 3 different series here. I noticed that number 2 and number 3, because they're raised to an n power, we can use geometric. The only time we can actually get a sum for a series is if the formula is geometric. So that's why I'm just going to focus on 2 and 3 because 1 is not geometric, so I wouldn't be able to find the sum. I could just tell whether it converges or diverges. So this one I'm going to try to write as a geometric series. This is going to be negative 8 times. I'm going to rewrite this as negative 1/3 to the n because that's, let me just see if I can, this is negative 8 times 1 over negative 3 to the n, and then notice I just put the 1 in parentheses with the 3. So that's basically what I was doing. So this one right here, I need to figure out the rate. The rate would be negative 1/3, and then my a is my first term. So if I plug 1 into this original formula right here, plugging 1 into this formula gives me positive 8/3. So I have my r and my a. And so from here I can get the sum. The sum is going to equal a, which is 8/3, divided by 1 minus the rate, which is negative 1/3. So this ends up getting me 8/3 over 4/3, and that will give me 8/3 times 3/4, and that does reduce to 2. So this series does converge to 2. So not going to be that, and it's not going to be that, and not going to be that. So it's either going to be B or E. So we've noticed for 2 for sure works. Now let's go down and try 3. I'm going to again rewrite 3 as a geometric series. This would really be 1/2 raised to the n power. So my r is going to be 1/2. My a, my first term, notice this starts at 0. So if I plug 0 into this formula, I will get 1. So when I do my sum is going to be 1 over 1 minus 1/2, which will give me 1 divided by 1/2, which does equal 2. So this sum also converges to 2. So 2 and 3 would be my answer. And again, number 1, I could actually, this series diverges because if you used the nth term test on it, we would get a limit of 2. And since the limit of 2 does not equal 0, the series would diverge. So that's not even really an option. Okay, number 10. If the function given by f of x equals x cubed has an average value of 9 on the closed interval from 0 to k, then k equals what? So I know what I'm going to do, something with an average value, which is 1 over b minus a times the integral from a to b of my function. So this is going to be 1 over, since it's on the interval 0 to k, it's going to be 1 over k times the integral 0 to k of my function, which is x cubed. And basically it's just saying once I get that answer, it should equal 9. All right, so just doing this, I'm going to get 1 over k times the integral of x to the third would be 1/4 x to the fourth, and I get to evaluate it at k and 0. So if I plug in k, I'm going to get 1 over k times 1/4 times k to the fourth, and then minus, if I plug in 0, I just get 0. So simplifying this, my k's can simplify to give me k to the third over 4. And I know, so that's as far as I can go, and I know that my answer has to equal 9. So if I cross multiply, I'm going to get k cubed is equal to 36. And to get rid of the third power, we can raise both sides to the 1/3 power. So k will equal 36 to the 1/3 power, which is choice E. Okay, number 11. Which of the following integrals gives the length of the graph y equals sine square root x between x equals a and x equals b, where a is between 0 and b? Okay, so what we need to do on this one, we need the length formula, and we've had a lot of length formulas, so hopefully you remember the right one. We'll just go from a to b. It's going to be the square root of 1 plus the derivative of x squared dx. So let's just fill in what we know. We're going to go from a to b, and it's still a to b. And then we'll have the square root of 1 plus, well, I'm going to come down here and do a side trip. We've got the sine of the square root of x. I'm going to let what's inside be my u. So I'm going to have the sine of u. The derivative of sine of u is cosine u times du. And just keeping in mind that if I have x to the 1/2, du will equal 1/2 x to the negative 1/2, which reduces to 1 over 2 square root x. So in this problem, I'm going to have y prime is equal to cosine of the square root of x times 1 over 2 square root x. So that's what y prime will be, or f prime, or whatever you want to call it. So we're going to have, this will be the cosine of the square root of x times 1 over 2 square root of x, and this whole thing will be squared dx. And I notice none of those are my choices, so I'm going to have to simplify a little bit. So we'll get the integral from a to b of the square root of 1 plus, since there's a times sign here, we can actually square both parts separately. So squaring cosine is going to give me cosine squared square root of x, and then times, just square the numerator and square the denominator. So 1 squared will be 1, and 2 squared will be 4, and the square root of x squared will be x. And so then from there, I think we are done, and I think I can find something that matches that, which should be choice D. And there we go. Alrighty, number 12. Which of the following integrals represents the area enclosed by the smaller loop of the graph of r equals 1 plus 2 sine theta? Alright, we have a little dilemma here because we don't get to use our calculator to graph this, and I'm assuming that most of you don't know what 1 plus 2 sine theta looks like. I know it's going to be some sort of cardioid with probably a loop in it, so I'm guessing it's going to look something like that, but I'm really not exactly sure what this is going to look like. So we are in a little bit of a dilemma, so I'm going to show you, especially if you did not have these memorized, which I definitely do not, how to get the answer anyway. Okay, so first of all, we know that the area of anything in polar is going to be 1/2 the integral of r squared d theta, and we know this is from a radial line to a radial line. So first of all, just by default, I'm going to cross off choice E, and I'm going to cross off choice D because they don't have a 1/2 sitting out in front. So I think I'm pretty safe doing that. And then the other thing, I'm going to cross off choice B because I know it's the radius squared and there's not a squared on that option. So I am left with choice A and choice C. So this is what I did to try to figure this out. All right, I looked at the values that they gave me. This one said from 7 pi over 6 to 11 pi over 6. Well, I know 7 pi over 6 is a little bit over pi, and 11 pi over 6 is a little bit before 2 pi. So we would go from here to here, okay? And then choice C has me going from negative pi over 6, which would be down pi over 6, or it's going to be starting here and going till I get to 7 pi over 6. So this one has me going all the way around. And I just looked at, well, if I'm looking for a smaller loop, if I had to pick one of those, the smaller distance that I'd have to travel would be the 7 pi over 6 to 11 pi over 6. So that's what I picked, and it was the right answer. So I think it was an okay way to look at it. All right, number 13, the third degree Taylor polynomial about x equals 0 of ln 1 minus x is what? Right, we do have a common Taylor polynomial for ln, but it is centered at 1. This one's centered at 0, so we have to do it the old-fashioned way. So my polynomial of degree 3 is going to be f of 0 plus f prime of 0x plus f double prime of 0x squared over 2 factorial plus f triple prime of 0x cubed over 3 factorial, because we need the third degree. Alrighty, so now I came down over here and we need to do a little work. So my f is equal to ln of 1 minus x. My f prime is going to equal du over u, since this is ln, so it's going to be negative 1 over 1 minus x. Okay, and I need to get my second derivative. I rewrote this as negative 1 minus x to the negative 1. So when I take the derivative of that, put my negative 1 down in front, I'm going to get 1 minus x to the negative 2 times the chocolate, so times the multiplying by the derivative of 1 minus x, which would be negative 1. So this will give me negative 1 minus x to the negative 2. And then I do need to take the derivative one more time. So I'll get the triple prime will then be my negative 2 out front. So I'll get 2, 1 minus x to the negative 3, but I still have to multiply by that chocolate. The derivative of 1 minus x is negative 1. So this will give me negative 2 times the quantity 1 minus x to the negative 3. And then I did actually simplify these a little bit because I'm going to have to plug 0 into them. So this actually was negative 1 over 1 minus x squared, and this would be negative 2 over 1 minus x cubed. All right, so now I'm ready to go ahead and plug things into my polynomial. F of 0, if I plug 0 in for my x, I just get the natural log of 1, which is 0. And then plus the first derivative, if I plug 0, well, I'm going to plug a 0 in right here, I end up getting negative 1x. And then plus the second derivative, if I plug 0 in here, I'll end up getting, again, negative 1 x squared, and 2 factorial is equal to 2. And then plus the triple derivative, if I plug in 0, I end up getting negative 2. So negative 2x cubed, 3 factorial is 3 times 2 times 1, which is 6. So now simplifying that, we'll get negative x minus 1/2 x squared minus 1/3 x cubed. And if I look at all of my choices, it is choice A. All right, and then number 14, we have dy dx is equal to y secant squared x, and y is equal to 5 when x equals 0, then y equals what? So although they don't say that, they are asking me to solve a differential equation. If I want to solve a differential equation, I know that I need to cross multiply. So we have dy dx is equal to y secant squared x, and I'm going to put a 1 underneath there, cross multiply. I'll get dy is equal to y secant squared x dx. I'll divide both sides by y. So I'm going to get dy over y is equal to secant squared x dx. I am now ready to take the integral of both sides. And just like we have du over u as natural log, dy over y is also natural log. So I'll get the natural log of y is equal to, the integral of secant squared is tangent x plus c. I'm ready to do the logarithmic loop. So when I do that, I'm going to get y equals ce to the tangent x. And now they did give me some initial conditions. They told me that when y equals 5 when x equals 0. So I'll have 5 equals ce to the tangent of 0, and I know that the tangent of 0 is equal to 0, and then e to the 0 is 1, which means c equals 5. So my final answer is going to be y equals 5e to the tangent x, which is choice C.